with the rank improvement course on EMFT, lecture number 4, Electrostatics Part 2. So quickly everybody join. Come on everyone. जल्दी से सभी लोग आ जाओ भाई. We are about to start the part number 2 of electrostatics. So first we are going to review whatever we covered in the previous session and then we are going to move ahead. ठीक है? पहले जो हमने कवर किया था वो देख लेते हैं. So I told you about the charge, that electrostatics is the study of charge at rest and charge is equal to Ne. So I told you the properties. It is transferable, it is associated with mass, it is conserved, additive, quantized, and it produces electric and magnetic field. Now conductors are where there are free electrons which can easily move. Insulators have very few free electrons. Conductors are copper, gold, aluminium. Insulators are glass, plastic, rubber. Here the charge distributed on the surface. Here charge can penetrate inside the insulator. There are three methods of charging: friction, conduction, and induction. Okay. So now for charge distribution, point charge, we show it as a Q. Line charge, charge density is Q by L. Surface charge, Q by area. Volume charge, Q by volume. Okay. So uniform means density is constant. Non-uniform means density varies. Then we saw the scalar form of the Coulomb's law, that the force between the two charges is K Q1 Q2 by R square. K is 1 by 4 pi epsilon. Q1 Q2 are the charges value along with the sign. R is the distance between the charges. Now epsilon is epsilon naught, epsilon R. Epsilon naught is the permittivity of free space. Epsilon R is the relative permittivity. Okay. Then we saw the vector form of Coulomb's law. It is K Q1 Q2 by mod R2 minus R1 square, R2 minus R1. So what is F12? Force due to 1 on 2. Okay. This is also known as R12. Okay, that is the vector from R2 to R1 to R2. R1 से R2 की तरफ बनने वाला vector. Now this was the electric field, that is the force per unit test charge. What was the meaning of the electric field? The region around a charge in which another charge will experience a force. So it is in the radial direction. Then we saw electric field due to infinite line charge. Okay. Rho lambda by 2 pi epsilon rho. For infinite sheet, sigma by 2 epsilon. This is the charge ring. This is the charge disk. This is the arc at the center. Okay. Then we saw dipole, when two equal and opposite charges are separated by a small distance and they work as a single system. There were two electric field. Axial was 2p by 4 pi epsilon r cube. And equatorial was minus p vector by 4 pi epsilon r cube. Okay. And when there is a charge, when the point does not lie on the axis, or the equatorial position, we break a dipole into two parts, p cos theta, p sin theta. P cos theta lies along the radial vector, along the distance vector. So electric field is axial. P sin theta is perpendicular to the position vector. So we take the equatorial formula. We saw the Gauss law, surface integral d dot ds is charge enclosed, where d is epsilon e. The differential form was del dot d is rho v. We saw the nature of Gaussian surface. For point charge we take a sphere. For line charge we take a cylinder. Sheet charge we take a cuboid. Spherical charge we take a sphere. So these are the formulas for different type of charge distribution. For spherical shell, inside the sphere, no electric field. Why? No charge is there. Outside it is same as the point charge. A uniformly charged sphere, inside the sphere It is directly proportional to radius outside, similar to a point charge. So whenever we take the electric field outside a sphere, the formula is same as if the entire charge is kept as a point charge at the center of the sphere. जब भी स्फीयर के बाहर इलेक्ट्रिक फील्ड निकालोगे ना, तो इलेक्ट्रिक फील्ड ऐसे आएगी जैसे स्फीयर का पूरा चार्ज उसके सेंटर पे मानो एक पॉइंट चार्ज की तरह रख दिया गया हो. ओके, so electric field inside a conductor is zero. Charge resides on the surface of the sphere just outside sigma by epsilon naught, and it is normal to surface. Charge density is highest at the sharp edges because the surface area is minimum. Now, induced charges inside the cavity, I told you the charge induced in the cavity is equal and opposite to the charge kept inside the cavity. Okay. So, whenever you are using Gauss law, use the symmetry. For multiple charges, use superposition theorem. Force and field are vector quantity. So, while adding them, convert them to component. For conductor, potential is constant, field is zero inside. For spherical distribution, when you are finding the field outside the sphere, treat it as a point charge at the center of sphere. Now, beta, we left some questions as homework. 3 point charges are located at various locations. It is asking the potential. So, देखो वैसे तो potential we will cover today, but still let me tell you, potential is a scalar quantity. It can be directly added. Okay. So now, first is 1.2 microcoulomb. Take K common. Okay, 1 by 4 pi epsilon is K. Now, what is the distance? We want at point 2. Point 2 minus 0.8 is 0.2 plus 0.8. 0.4 minus 0.6. So, I am taking the distance, okay? Plus, the second charge is minus 0.75 microcoulomb. Okay? ये questions try किए थे भाई. Now, it is at 0.2 minus 0.6. 0.4 minus 0.7. 1.2 plus 0.2 का square. Again, 0.2. I am subtracting the coordinates of the charge from the coordinates of the point where I need the potential. जिस पॉइंट पे पोटेंशियल निकालना है उसमें से चार्ज के कोऑर्डिनेट सब्ट्रैक्ट कर रहा हूं मैं. Now k is 9 into 10 की पावर 9. This is micro 10 की पावर minus 6. So 9000 will stay outside. Four eight two 5.7. मैंने 1 by 4 pi epsilon naught रखा है divided by 2.7. तो 1787 point 1.78. ओके, यही आ रहा है भाई 1.787. एक बार कंफर्म कीजिए. आर यू गेटिंग द सेम आंसर 1.787? Okay, next. Due to a charge of 500 microcoulomb uniformly distributed over the circular disk, I need the force on a point charge. Now we already know the electric field due to a circular disk. Okay. So if I can find beta, rho s will be q by pi r square and the height of the point is 5 meter. The radius is also 5 meter. Because it is written r less than equal to 5. Now 1 by 2 pi epsilon is 18 into 10 की power 9. 1 by 4 pi epsilon is 9 into 10 की power 9. 2 pi epsilon 18 into 10 की power 9. Due to microcoulomb 10 to the power minus 6. 500 into 18 into pi 1000 by 25. The 0.312. Now force is equal to beta charge into electric field. Charge is 50 microcoulomb. 16.56. Okay. AZ. देखो why I am saying AZ? A disk in XY plane. Okay, why XY plane? Because Z is 0. So electric field is perpendicular to disk that is along ZX. So Z axis के along electric field आएगी. Okay, बेटा? It will be along Z axis. Very good, Bakshi ji. The line described by x equal to y equal to minus 4. So when I am fixing the x and y coordinate, so this line is parallel to Z axis. Okay. It has a uniform charge density. Find the electric field. So first beta, let me tell you how to write the row vector. When it is parallel to Z axis, take the difference of the x and the y coordinate. So see the point where you need to find the field and see the coordinate of the charge. So minus 2, I cap, minus 1, minus 4, j cap. So minus 4i plus 3. Rho is 5. Okay. Now lambda is 20 into 10 to the power minus 9. Now understand 1 by 4 pi epsilon is 9 into 10 की power 9. So 1 by 2 pi epsilon is double of it. (360 by 25, 12, 14.4. Minus 57.6 plus 43.2. Okay, understood now beta how to take the perpendicular distance from the line charge. अब clear हुआ कैसे निकाला जाता है? Uniform sheet charge is located at Z equal to 5. Uniform line charge is at Z equal to -3. I want the electric field at X -1, 0. Now, first let us talk about sheet charge. Sheet charge is at Z equal to 5. Point Z coordinate is Z equal to. Always subtract point and charge. Point में से charge घटाइए. So this is the direction of the electric field. Point में से charge का coordinate गिराना है. So rho s is 1/3 pi. One by pi epsilon is 36. This is because of the sheet charge. Now beta, because of line charge. Okay, subtract the y and the z coordinate of the charge from the point. Point में से charge के लिए घटाइए. Ten की power 9 will be cancelled. Nano and 18 into 10 की power 9. 25. 18 by 9, 2. 8j minus 6k. 8j minus 12k will be the total option. You just have to add 8j minus 6k and minus 6k, so 8j minus 12k. For the charge distribution, the electric field at 2, 0, 2. Okay, now the sheets are given in terms of x. The x coordinate of the point is 2, charge is 0. Point minus the charge. Minus I minus I minus I. For this it is a line. तीसरे वाला line charge है. O vector is subtract the x coordinate of charge from the point. Charge from the point. Now what did I tell you? If you convert the unit vector as vector upon mod, you can write like this. So it is 2 nanocoulomb per meter. Now 1 by 6 pi epsilon. 1 by epsilon can always be written as 36 pi into 10 की power 9 बाय एप्सिलॉन नॉट, ये जो नैनो है ना ये कट जाएगा, द चार्ज ऑल्सो कंटेन्स नैनो। 1/2 पाई एप्सिलॉन इज 18 इंटू 10⁹ 4 36 9। by 3। चलिए गलत, 21 आई कैप, बी ऑप्शन। Infinite plane sheets are kept at -2, 0, 2 having surface charge densities. Now electric field at 5, 3 -1, 6 -2, 1, 4 -7, 8 are given. The third value I think is missing. अच्छा AZ cap है, ठीक। The value of rho S1, rho S2, rho S3. Now beta, this is very easy actually. What you have to understand is Z coordinate of a charge is given. So electric field due to a sheet charge is sigma by 2 epsilon. Okay. Then it is n cap. How to take the n cap? N cap is taken by subtracting the coordinate of the point and the charge. So first of all, 5, 3 minus 1. Electric field is 0. OS 1 by 2 epsilon. Now how to write n cap? The z coordinate of rho S1 is -2, point is -1. Now z coordinate is 0, point is -1, magnitude is 1. I am dividing by the magnitude of the distance. Z coordinate is 2, point is -1. So the magnitude will be 3, so divided by 3. Okay. So it will be plus k cap. Take 2 epsilon common. First equation. Okay. Similarly for second, the z coordinate is 1. So it is -2az. 1 minus 2 k cap, magnitude is 1. Okay, that way you have to form the equation. 1 minus 0 k. क्या बेटा? 1 minus ठीक है. So take 2 epsilon here. This is second. So that way you can form a third equation, beta. Let me write down the third equation. 4 minus 7, 8. Okay. So it is AZ cap 2 epsilon. OS1 will be positive. 8 plus 2. 8 minus 0, it will also be positive. 8 minus 2 will also be positive. Now you have to solve the three equations and find rho S1, rho S2, rho S3. Answer will be C. Okay, answer will be C. Clear हो गया? Answer will come out as C. Uniform line charge of 20 nanocoulomb per meter each lie in the Z equal to 0 plane. XY plane. Okay. The total electric flux leaving a spherical surface of R equal to 2.5 is. Now total flux is nothing but charge enclosed. So I have to figure out the charge enclosed within a sphere. Let me take a sphere, बच्चों. Okay, this is my sphere. Now what I will do is, I will choose this axis as X, Y. Now charges are lying in the XY plane at X equal to 0, 1, 2. X0 माने along the Y axis. Okay. Now at 1 they will lie, at 2 they will lie. Similarly, they lie in the left side. Okay. Now the other charge that will be there will lie outside. So it does not contribute to the charge enclosed. 1, 2, 3. Because the radius of the sphere is 2.5. Understood, beta? Now, I need to know the charge enclosed. Charge enclosed will be charge density. Charge enclosed will be charge density into length. अब मेरे को लेंथ चाहिए होगी. The length of this will be beta. The length of this is 2.5, right? ये 2.5 है तो length will be 5 simply. But what about the other charges? For other charges, beta, we have to figure out. So I will draw a line like this. This length will be 2.5. So what is this? By Pythagoras, 2.5 square minus 1 square. Similarly, I will draw another line here. Okay? The base is 2 and the hypotenuse is 2.5. So this length will be 2.5 square minus. Okay. So charge enclosed will be 20 nanocoulomb per meter. The length of first charge is 5. A moment. तो देखो पहले चार्ज का लेंथ हुआ 5, दूसरे वाले का 2 इंटू, and for the third one 2 into. Now similar charges are present on the left side. Okay, why you are taking 2 times, sir? It is because of above and below the, okay. So we are taking half the length and that is why we are doubling. Now what it will become? 5 plus 4 times under root 6.25 minus 1 plus 4 into 1.5. 20.165. So 403.3. I'm getting 403.3. Let me check. 403.3. क्लियर हुआ? पीवाई की सीरीज कितनी देर की होगी बेटा? जब सेशन लेंगे तभी आइडिया लगेगा कितना टाइम लगेगा उसमें। वैसे तो मैं 1.5 से 2 घंटे प्लान कर रहा हूँ, बाकी देखते हैं स्टार्ट करने पे। बताइए भाई, क्लियर हो गया यहाँ तक? चलें आगे? Shall we move ahead? चलो। So now today we will talk about electric potential and the potential energy. Now what is the meaning of potential energy? Whenever beta in a system we have certain arrangement of charges, charges are kept at certain location. The energy of the system because of that arrangement of charges is called potential energy. So yesterday we studied electric field is force per unit charge, where F is the force on a test charge kept near to a source charge and Q is the value of test charge. So we found the force as Q into electric field. Now if Q is positive, the force is in the same direction as the field. If Q is negative, force is opposite to the field. So you can see for a positive charge, force is tangential to the electric field line. For a negative charge, force is in the opposite direction to the electric field line. So now beta, we know the concept of work done. Work done is the force into displacement. So whenever we keep a positive charge under the influence of electric field, it will start to move in the same direction as electric field. But if you want to move it opposite to the field, see, the natural tendency of a charge, a positive charge, is to move in a direction parallel to field. But what if I want to move it opposite to the field? I have to apply a force externally. I have to push the charge in a direction opposite to the electric field. For that, beta, I need to do work. मुझे मेहनत करनी पड़ेगी अगर चार्ज को फील्ड के अपोजिट लेके जाना है. And what will be the effort? Force is QE into displacement. So you can write it Q into E delta X or work done per unit charge is E delta X. ठीक है? So always remember beta, whenever you need to work against the natural tendency of any system, you need to work on the system. सिस्टम का जो स्वभाव है अगर उसके विपरीत उससे काम कराना है तो उस पर मेहनत करनी पड़ेगी. So now beta, if the displacement is opposite to the force applied by electric field, the work done is positive. अगर आप इलेक्ट्रिक फील्ड से अपोजिट उसको, जो उसका नेचुरल मोशन है उससे अपोजिट कराओगे काम, तो आपका वर्क डन पॉजिटिव आएगा. एंड इफ डिस्प्लेसमेंट इज इन द सेम डायरेक्शन एज द इलेक्ट्रिक फील्ड, दैट मीन्स द चार्ज इज मूविंग in the direction of electric field, in the direction of natural tendency, work done will be negative. अगर चार्ज उसी डायरेक्शन में मूव करे जिसमें इलेक्ट्रिक फील्ड के कारण वो करना चाहता है, तो ये आपका वर्क डन नेगेटिव आता है। तो वर्क डन पर यूनिट चार्ज इज कॉल्ड एज द पोटेंशियल डिफरेंस। So whenever you move a charge from one point to the other, then work done divided by the charge is the potential difference. It is taken, work done is minus Q times initial to final E dot dl. Why negative? Because if E and dl are in the same direction, dot product positive, work done negative. If E and dl are opposite, dot product negative, work done is positive. माइनस साइन क्यों लगा रहा हूं बेटा? क्योंकि अगर इलेक्ट्रिक फील्ड के डायरेक्शन में चार्ज गया तो वो उसका नेचुरल मोशन है, तो वहां मेरे को मेहनत नहीं करनी पड़ी, तो मेरा वर्क डन नेगेटिव आया। इलेक्ट्रिक फील्ड से अपोजिट ले जाने के लिए मुझे मेहनत करनी पड़ती है, तो मेरा वर्क डन पॉजिटिव आना चाहिए। माने इलेक्ट्रिक फील्ड और डिस्प्लेसमेंट अपोजिट होंगे तब वर्क डन पॉजिटिव आना चाहिए, पैरेलल होंगे तो नेगेटिव आना चाहिए। तो डॉट प्रोडक्ट पैरेलल के लिए पॉजिटिव आएगा तो वर्क डन नेगेटिव, डॉट प्रोडक्ट अपोजिट के लिए नेगेटिव आएगा तो वर्क डन पॉजिटिव। तो व्हेन वी टेक वर्क डन पर यूनिट चार्ज, इट इज द पोटेंशियल डिफरेंस। तो पोटेंशियल डिफरेंस इज नेगेटिव ऑफ इंटीग्रेशन ऑफ इलेक्ट्रिक फील्ड फ्रॉम इनिशियल टू फाइनल पोजीशन। पोटेंशियल डिफरेंस निकालने के लिए इलेक्ट्रिक फील्ड का इंटीग्रेशन करिएगा, लाइन इंटीग्रेशन, इनिशियल टू फाइनल, उसका नेगेटिव ले लीजिएगा। ठीक है, तो दिस इज बेसिकली लाइन इंटीग्रल। ठीक है, ये लाइन इंटीग्रल बना। तो डेल्टा वी इज माइनस ई डॉट डीएल। अगेन बेटा, इफ ई एंड डीएल आर इन द सेम डायरेक्शन, डॉट प्रोडक्ट पॉजिटिव, डेल्टा वी नेगेटिव। ई एंड डीएल अपोजिट डायरेक्शन, डॉट प्रोडक्ट नेगेटिव, डेल्टा वी विल बी पॉजिटिव। Now, beta, what does this mean? That if the displacement and electric field are in the same direction, delta V is negative, माने potential decreases. So, potential always decreases in the direction of electric field, but the potential will increase because delta V positive माने final is more than initial. So, potential will increase opposite to the electric field. So, what is potential? We talked about the potential difference when we move a charge from one point to the other under the influence of electric field. So we know the difference of potential. What if I want to define the potential at a point? In that case, beta, I have to take a reference. Reference is the point where potential zero. We have to take a reference, that is where the potential is zero. We call it ground. We usually take the ground at infinite distance because beta, when you are at infinite distance from the charge will not have any effect on the point. अगर आप चार्ज से infinite distance पे चले जाओ तो वहां चार्ज का कोई भी असर नहीं पहुंचने वाला। इसी वजह से कहां लिया जाता है ग्राउंड? ग्राउंड इज टेकन एट द पॉइंट वेयर इनफिनिट डिस्टेंस इज प्रेजेंट। जहां इनफाइनाइट डिस्टेंस होता है बेटा, उसको ग्राउंड कहा जाता है। इज दैट क्लियर? नाउ, so whenever you bring a charge from infinity to a point, the potential difference will be called as potential of the point. जब आप किसी चार्ज को लेकर के आओगे इन्फिनिटी से किसी एक पॉइंट पे, तो जो पोटेंशियल डिफरेंस होगा ना, वही आपका पोटेंशियल कहलाएगा। क्योंकि इन्फिनिटी पे पोटेंशियल जीरो है, तो जीरो के रेस्पेक्ट में जब डिफरेंस लोगे तो Vx ही आएगा। बट आई मीन टू से द पोटेंशियल डिफरेंस विल बी रिटन एज Vx माइनस V infinity. Now V infinity is zero, so it is Vx. It is Vx. So how do you define the potential? Work done per unit charge in moving a charge from infinity to a point. When we move a charge from infinity to a point, the work done per unit charge is called as, it is called as the potential. It is called as the potential. ठीक है? So now, why there is a negative sign, beta? Because potential decreases in the direction of field, potential increases opposite to the electric field, and that is why negative sign is there. Now, how do we find out the potential of a point charge? We will take negative of the integration of electric field from infinity up to a distance r for a point charge, and the potential is given like this. Q by 4 pi epsilon r. It is Q by 4 pi epsilon r. And potential is a scalar quantity, so you need not worry about the direction. Okay, next. Next, beta, what is the potential of a uniformly charged conducting sphere? Now, what do we understand when we talk about a uniformly charged sphere? The conductor always has a charge on the surface, not inside the volume. कंडक्टर का चार्ज हमेशा उसकी सतह पे रहता है, उसके अंदर नहीं रहता. Because of which charge enclosed inside the sphere is zero. So electric field is zero. And electric field outside, I already told you, it is same as a point charge where the entire charge is at the center of the sphere. So when the electric field is taken outside the sphere, it is same as if the entire charge is concentrated at the center. Now, beta, when electric field is zero inside, the potential becomes constant. So, the potential of the conducting sphere inside the sphere is same as the potential at the surface. तो ये याद रखेंगे बेटा, the conducting sphere has zero electric field inside, and whenever electric field is zero, it means the potential is constant. So potential inside is constant. It is same as the potential on the surface. And outside, it is just like a point charge. It varies as 1 by r. बाहर ये point charge वाली ही value होती है और ये 1 by r की तरह vary करता है. Okay, it will vary like 1 upon r. Is that clear? Now, when we talk about charge conservation, remember, whenever you connect two conductors together directly by a wire, a conductor, then the charge will be redistributed in such a way that their potential become equal. Okay? So, when two conductors are connected, the charges are redistributed such that V1 equal to V2. So see, initially beta, the first body had a charge Q, the second body was at zero charge. So the total charge was Q plus 0. After connecting them, the charge on the first body became Q1, on the second it became Q2. Now Q1 plus Q2 should be equal to Q because of the charge conservation, and now their potential should be same. So you can say Q1 by 4 pi epsilon RA should be same as Q2 by 4 pi epsilon RB, because the potential on the surface of a sphere is same as the point charge. अगर आपको सरफेस पे पोटेंशियल निकालना है तो पॉइंट चार्ज वाला ही फॉर्मूला लगता है. तो Q1 by 4 pi epsilon RA equal to Q2 by 4 pi epsilon RB. So now beta, you have two equation. Q1 is Q2 RA by RB and Q1 plus Q2 is Q. So charge is being redistributed in the ratio of their radius. तो चार्ज जो है रेडियस के रेशियो में रीडिस्ट्रीब्यूट हो जा रहा है बेटा, ठीक है. सो वी आर बेसिकली redistributing the charge as per the radius. So the larger sphere will hold more charge, the smaller sphere will have less charge. जिसका रेडियस ज्यादा उसका चार्ज भी ज्यादा आएगा. Now if you want the ratio of electric field, it is same as the point charge q by 4 pi epsilon r square. So it is q1 by q2 into rb by ra square. q1 by q2 is ra by rb. So ra by rb into rb by ra square is rb by ra. So the ratio of electric field is inverse ratio of radius. So electric field varies in the inverse ratio of radii and the ratio of charge is same as the ratio of radius. समझ गए बेटा? Now if you want the ratio of charge density has the similar expression as the electric field. बस एक एप्सिलॉन ही तो गायब है, बाकी फॉर्मूला सेम है. तो अगेन it is the inverse ratio of radius. It is the inverse ratio of radius. And if you take the ratio of energy density is half epsilon E square. So it is proportional to electric field square. So it is the square of the inverse ratio of radius. ठीक है, half epsilon E square होती है. So it is the square of inverse ratio of radius. So that is energy density. That is how charges are redistributed. ये समझ में आया बेटा अच्छे से? ये समझ में आया? Now if we talk about earthing माने बेटा connecting a body to the earth is always taken at zero potential. So we assume beta that earth is a infinite reservoir of charge. It has equal amount of positive and negative charge. So the net charge on the earth is zero. Therefore the potential is zero. So whenever you earth a conductor, you are forcefully making the potential of the conductor zero. Now earth can supply or take the charge away from the body. जब आप एक बॉडी को अर्थ से कनेक्ट कर रहे हो तो अर्थ उसे चार्ज दे भी सकती है और उससे ले भी सकती है. यानी देन यू कैन नॉट कंजर्व द चार्ज ऑन द बॉडी. आप बॉडी का चार्ज कंजर्व नहीं मान सकते. When it is getting connected to the earth, it will be charged. Now its charge can be positive, its charge can be negative, but the charge will be such that its potential becomes zero. मेरी बात समझ में आ रही है कि इसका चार्ज पॉजिटिव नेगेटिव कुछ भी आ सकता है, लेकिन ऐसा आएगा कि नेट पोटेंशियल आपका जीरो आ जाए. ओके, so now let us see this. I have a conducting sphere. I bring a positive charge near to the sphere. Now when I am bringing a positive charge near to the sphere, beta, a negative charge will be induced on the sphere. And now when you connect it to earth, you are making the potential zero. Then what is the charge of the sphere? Charge kitna aega sphere pe? So now beta, if you want to see the potential at the center, the potential due to point charge will be kq by x. What about the potential due to charge on the surface? The potential inside a conducting sphere is same as the potential on the surface. So it is kqc by r. kqc by r. ठीक है? So qe will be minus qr by x. बेटा ठीक है? Now charge induced will be minus q into capital R by x. Point समझ में आया? ये बात समझ में आई बेटा? मैंने क्या किया? Due to the point charge, I am directly seeing the distance to the center. Due to the induced charge, I am taking the potential same as the potential on the surface. Now, how does the charge distributes on a conductor surface? Now beta, whenever you give any conductor of arbitrary shape, you give it any amount of charge, the charge will be distributed in such a way that the potential becomes the same and electric field becomes the zero. Potential becomes the same. अब ये मैंने अभी आपको derivation कराया ना, at same potential, charge is directly proportional to radius. Charge density inversely proportional to radius. Electric field is inversely proportional to radius. What do you understand by this? On a conductor where the curvature is different at different points, the charge is distributed such that potential is same. Now wherever the conductor shape is sharp, curvature is small, the radius is small, charge density will be large because it is inversely proportional to R. Electric field will be large, it is inversely proportional to R. And there you can observe the corona discharge. And that is exactly what I told in the last lecture, that corona is observed at the sharp edges. Okay, beta? So whenever you have a conductor of an arbitrary shape, you see that charge is more concentrated at the sharper edges. The electric field is higher at those points. Now, what is a equipotential surface? It is a surface, beta, where potential is constant over the entire surface. So mainly a conductor acts as a equipotential surface because on the body of the conductor potential is same. So you can say that potential difference is zero. Between any 2 point potential difference zero. Now what is potential difference? Minus E dot dl integration. Okay. So now beta delta V, if this is zero, if dot product is zero, it means electric field and dl vector should be perpendicular. Now dl vector is along the surface. So electric field should be perpendicular to dl vector or perpendicular to surface. लॉजिक समझे? अगर पोटेंशियल डिफरेंस जीरो तो E और dl को परपेंडिकुलर होना पड़ेगा. अब dl तो सरफेस के अलोंग है, इलेक्ट्रिक फील्ड उसके परपेंडिकुलर माने के सरफेस के परपेंडिकुलर. So Gaussian surfaces are equipotential surface because when I told you about Gaussian surface, I told you choose Gaussian surface such that electric field is perpendicular to the Gaussian surface. मैंने बोला था Gaussian surface ऐसा चुनिएगा जिसके परपेंडिकुलर इलेक्ट्रिक फील्ड आनी चाहिए, तो Gaussian surface भी equipotential surface ही हुआ. So the lines of force or the electric field lines will be perpendicular to the equipotential surface. Equipotential surfaces cannot intersect each other because at one point you cannot have two values of electric potential. एक equipotential surface के लिए एक value potential की होती है, तो जहां दोनों कट करेंगे उस पॉइंट पे दो value potential की मिलेंगी, which is not possible. Now, whenever you have a charged conductor, it acts like a equipotential surface because potential of the entire body is the same. Now, equipotential surfaces are very close to each other when electric field is strong because potential changes rapidly. अगर electric field high है, तो potential कम distance में ज़्यादा change होता है because electric field is dV by dl. So if electric field is high, potential changes by a large amount over small distance. So potentials, equipotential surfaces are crowded. Now, how to find the work done using potential difference? Work done is charge into potential difference, but take final minus initial potential. But if it is a equipotential surface, the potential at both the point will be same, which means the work done will be zero if you move a charge over a equipotential surface. अगर एक चार्ज को equipotential surface पे मूव कराओगे तो work done zero होगा, but if you move it from one surface to the other, you have to do work because two surfaces will have two different potentials. So now you see, this is my point charge, the equipotential surfaces are spheres having different potentials. एक पॉइंट चार्ज के लिए इक्विपोटेंशियल सरफेस स्फेरिकल होता है, सेम शेप एज द गॉसियन सरफेस. यू कैन सी दैट इलेक्ट्रिक फील्ड is in the radial direction, so it is perpendicular to the surface of the sphere. आपको एक पॉइंट चार्ज की इलेक्ट्रिक फील्ड पता है, AR कैप में आती है, तो हर सरफेस के परपेंडिकुलर आपको मिलती है. Now you saw that potential difference is integration minus E dot dl. Similarly, electric field is derivative of the potential difference. It is actually minus negative of the gradient. Now gradient tells you the maximum rate of increase. Gradient tells you the direction of maximum rate of increase. So negative of gradient माने maximum rate of decrease. ठीक है, direction of maximum rate of decrease. ठीक है, डायरेक्शन ऑफ मैक्सिमम रेट ऑफ डिक्रीज. इज दैट क्लियर बेटा? जस्ट गिव मी अ मोमेंट, देन आई विल टॉक अबाउट द एनर्जी. हाँ जी. So now beta, what is the potential energy? It is basically the work done in assembling, in making a system of charges by bringing charges one by one. एक एक करके चार्जेस को जोड़ करके सिस्टम बनाने में जो मेहनत हुई उसे हम कहते हैं potential energy of a system. The simple formula is half summation of Qi Vi. What is Qi Vi? There are n charges, Q1, Q2, Q3, Q4 up to Qn. N charges हैं. And the potential at the location of a charge because of the other n minus 1 charge is Vi. So suppose I take a charge Qi. I find the potential at the point where Qi is located because of the remaining n minus 1 charges, that is Vi. तो जहां पे Qi रखा है वहां बाकी चार्जेस के कारण जो पोटेंशियल वो Vi, Qi हो गया चार्ज का वैल्यू, तो ऐसे सबको सम करके हाफ कर लीजिएगा. ओके, नाउ इफ इट इज नॉट डिस्क्रीट चार्ज बट कंटिन्यूअस चार्ज, फॉर लाइन चार्ज टेक अ लाइन इंटीग्रेशन ऑफ हाफ रो L into V. For surface charge, take surface integration half rho S into V. For volume charge, take volume integration half rho V into V. Energy stored can also be written like this: volume integration of d dot E dV. D dot E dV. Or E can be written as d by epsilon, so mod d square by epsilon. Or d can be written as epsilon E, so half mod epsilon mod E square. This is called as energy density. यानी एनर्जी डेंसिटी क्या है? एनर्जी पर यूनिट वॉल्यूम So energy is what? Energy is the volume integration of energy density. हमने देखा in the formula of energy I am getting the volume integral of half d dot e. So half d dot e by default becomes the energy density, that is energy per unit volume. Energy per unit volume ये मेरा बन जाता है. So if electric field is constant, that is uniform field which is independent of the coordinates, energy density will be constant. So energy will be energy density into volume. तो अगर आपकी इलेक्ट्रिक फील्ड कांस्टेंट आती है ना, तो एनर्जी डेंसिटी भी कांस्टेंट बनती है और फिर एनर्जी होती है डेंसिटी इनटू वॉल्यूम. सिंपल, यू डोंट हैव टू इंटीग्रेट. नाउ दिस फॉर्मूला यू कैन रिमेंबर फॉर अ स्फेरिकल शेल. द टोटल पोटेंशियल एनर्जी इज Q by 8 pi epsilon r. It is also called as the self energy. क्या कहलाता है? सेल्फ एनर्जी. सेल्फ एनर्जी माने इसकी एनर्जी खुद के चार्जेस की वजह से. ठीक है, 8051 माइक्रो कंट्रोलर मैंने करा रखा है इस चैनल पे, चेक करो. Now, if the sphere is insulating, that is, it contains the charge within the bulk, and total energy is 3q square by 20 pi epsilon r. So here q square by 8 pi epsilon r, and here 3q square by 20 pi epsilon r. Okay. Now, energy and potential of a insulating sphere. This we have already seen, beta. In case of a insulating sphere, the electric field inside the sphere varies linearly with the distance. Distance के साथ linearly vary करती है. Outside it varies as 1 by r square. Now the potential inside is given by this, and the potential outside is same as that of point charge. अब आप ये सोच रहे होगे सर पोटेंशियल अंदर कैसे निकाला, मैं आपको बताता हूं. Suppose I take a sphere. Now I want the potential at a distance r. Okay. Now beta, now I want to know the charge enclosed. Okay, charge enclosed. बेटा करा चुका हूं माइक्रो कंट्रोलर, चेक करो इस चैनल पे. चार्ज एनक्लोज्ड rho v into 4 by 3 pi r cube. Now rho v is what? Total charge by total volume. Okay. So q r by r. Now what is the potential at a distance r? It is same as that of a point charge. ठीक है, this is due to charge inside. Now what about the charges that are outside the sphere? Yes, they do not contribute to the electric field, but they will contribute to the potential. माना वो इलेक्ट्रिक फील्ड में कोई योगदान नहीं देते बेटा, लेकिन वो पोटेंशियल में देंगे. ठीक है, why? Because you know, even if the charge lies outside a sphere, अगर चार्ज अगर बाहर भी लाई करता है बेटा, then also the potential inside is same as the potential at the surface. तो सपोज बेटा मैंने dx width का ये लिया. Now dq is rho v into volume q by 4 by 3 pi r cube. बात समझ रहे हो मेरी? स्फीयर में भी तो आपने देखा ना, चार्ज भले ही बाहर लाई कर रहा हो बट उसका पोटेंशियल अंदर तो आता ही है. 3qx square by r cube. Okay, this is dq. Now potential inside is equal to potential at the surface. Okay. dq by 4 pi epsilon x. That is same as the potential at the surface. Now x will vary from where to where? From small r up to capital R. Outside the pink sphere, integration of x will be x square by 2. Now you have to add the two values. Okay. So add the two values. Two q by 8 minus 3q by 8 by 8. Okay, that is the sum. देखो यही आ रहा था. Two r square by 4. For the surface inside. A minute. मैं एक बारी बताओ कहीं पे अगर गलती हो रही है. वर्क डन जीरो बेटा इक्विपोटेंशियल सरफेस पे होता है क्योंकि उसके किसी भी दो पॉइंट के बीच में पोटेंशियल डिफरेंस जीरो है और वर्क डन होता है चार्ज इनटू पोटेंशियल डिफरेंस. ठीक है, चेक कर लेता हूँ एक बारी. बताओ अगर डेरिवेशन में कुछ गड़बड़ लग रहा है. यही आएगा जो मेरे वाला है ना, Q/8πε r माइनस, ठीक है, तो ये बनता है। चल, now we will talk about a dipole. In dipole, beta, we saw there are two type of electric field, one on the axis, one on the equatorial position. Same way, here also we will do the same thing. But remember, it is very easy to find potential because it is a scalar quantity. So the potential on the axis at a distance r, where r is much greater than length of dipole, is P/4πε r square. So even if you forget, beta, it is very easy. Find the potential due to each charge. दोनों चार्ज की वजह से पोटेंशियल निकाल लेना, and then just add them. One will be negative, other will be positive. Very easy. And on the equatorial plane, beta, this point P on the equatorial plane, okay, it is equidistant from both the charges, and charges are equal and opposite, so the potential will be equal and opposite. Net potential will be 0. दोनों चार्ज की वजह से पोटेंशियल बराबर और एक दूसरे का नेगेटिव आएगा तो 0 आएगा, तो इट विल एक्ट लाइक अ इक्विपोटेंशियल सरफेस। तो ये जो बीच में से जाने वाला परपेंडिकुलर बाइसेक्टर है वो क्या होगा, वो आपका इक्विपोटेंशियल सरफेस होगा। सरफेस में तो पूरा चार्ज क्यों ही ना आएगा सर, मैं समझा नहीं क्या पूछना। बेटा मैं ऑफलाइन नहीं पढ़ाता हूं, ठीक है। चलिए, for any point you can resolve a dipole into two parts, again p cos theta along the r vector, p sin theta perpendicular. For perpendicular it is equipotential, so this is equatorial for p sin theta, therefore potential due to p sin theta will be 0. Only because of p cos theta it will be. So p cos theta can be written as p dot r cap, because r cap is the unit vector in the radial direction. Now beta, once we have the potential in the spherical coordinates, if you want the electric field ना मेरे बच्चों, if you want the electric field, it is minus gradient of Vp in spherical coordinates. आपको ग्रेडियंट निकालने तो आते ही स्फेरिकल कोऑर्डिनेट में, तो इवन इफ यू फॉरगेट द इलेक्ट्रिक फील्ड, नो इश्यूज, जस्ट रिमेंबर द पोटेंशियल, यू कैन फाइंड द इलेक्ट्रिक फील्ड। नाउ हाउ मच वर्क इज डन इन रोटेटिंग अ डाइपोल? In the previous lecture I told you, whenever a dipole is kept in an electric field, it experiences a torque. और वो इंसुलेटिंग स्फीयर वाले में पहले वाला ही लिखा हुआ है, चेक कर लेना एक बार, करेक्शन कर लेना अगर कहीं कैलकुलेशन मिस्टेक हो, यही आना चाहिए। अब सुनिए, नाउ 3/8 वाला समझ नहीं आया। 3/8 वाले मैंने क्या बोला है? मैंने बोला अगर मुझे r डिस्टेंस पे निकालना है, ठीक है जी, अब मैंने स्फीयर को दो हिस्सों में बांट लिया, एक 0 से r रेडियस तक और एक r से कैपिटल R तक। 0 से r वाला चार्ज अंदर लाई कर रहा है, अंदर की वजह से जो पोटेंशियल आता है पॉइंट चार्ज वाला आता है। तो मैंने 0 से r तक में निकाला, कितना चार्ज आया, वॉल्यूम चार्ज डेंसिटी इनटू वॉल्यूम, और इस पे पॉइंट चार्ज का फॉर्मूला लगा दिया। अब ये जो बाहर बचा स्मॉल r से कैपिटल R, अब अगर मैं यहां पे एक पतला सा फिलामेंट ले लूं x रेडियस का, dx विड्थ का, तो मुझे बताओ एक स्फीयर जिसके सरफेस पे चार्ज होता है उसके अंदर कितना पोटेंशियल होता है। अभी मैंने बताया था कि सरफेस के बराबर ही होता है, क्योंकि इलेक्ट्रिक फील्ड 0 होती है तो पोटेंशियल का ग्रेडियंट 0 होता है, पोटेंशियल कांस्टेंट आता है, तो अंदर वही आएगा जो सरफेस पे आएगा। अब मैंने पतले से फिलामेंट का चार्ज निकाला, रो वी डीवी करके निकाल लिया। इसके सरफेस का पोटेंशियल निकालना था, इसका रेडियस x है तो सरफेस पे ये आएगा, तो ये मेरे को dv मिल गया। अब ऐसे सभी फिलामेंट के पोटेंशियल को मैं इंटीग्रेट करूंगा, कहां से कहां तक, स्मॉल r से कैपिटल R, क्योंकि ये फिलामेंट ऑरेंज वाले स्फीयर के बाहर लेने हैं। अब ये आ गया, ये बाहर वाले स्फीयर्स का पोटेंशियल आ गया और ये अंदर वाले का आ गया, तो टोटल मैंने दोनों को ऐड कर दिया बस। ठीक है, चलिए। नाउ व्हाट आई वाज टेलिंग यू इज बेटा that we know that the torque on a dipole is Pe sin theta. So now when the dipole rotates, because of the torque there will be work done. So work done comes out as minus P dot E or minus Pe cos theta. That is the work done or the energy. So energy will be minimum when theta is 0, it will be minus Pe. It will be maximum when theta will be 180. So that is P into E. तो मिनिमम एनर्जी आती है व्हेन डाइपोल इज पैरेलल टू द फील्ड और मैक्सिमम आती है व्हेन डाइपोल इज अपोजिट टू द फील्ड। ओके, नाउ डाइलेक्ट्रिक, व्हाट इज द डाइलेक्ट्रिक बेटा? डाइलेक्ट्रिक इज नथिंग बट अ इंसुलेटिंग मटेरियल, बट व्हाई डू वी कॉल इट डाइलेक्ट्रिक? बिकॉज इट हैज डाइपोल्स। व्हाट इज अ डाइपोल? इक्वल एंड अपोजिट चार्ज सेपरेटेड बाय अ स्मॉल डिस्टेंस. So because it has two type of charges, positive and negative, it is known as a dielectric. But these charges are a part of dipole. Now beta, dipole is formed inside a atom. Like when inside a atom you have nucleus and electrons are revolving around the nucleus. Then in that case beta, within a atom I have positive and negative charges. एक एटम के अंदर ही पॉजिटिव और नेगेटिव चार्जेस होते हैं. नाउ नाइदर द न्यूक्लियस नॉर द इलेक्ट्रॉन्स कैन फ्लो सेपरेटली फ्रॉम द एटम. ना ही तो एटम का न्यूक्लियस ना ही उसके इलेक्ट्रॉन अलग जा सकते हैं. So that is why I say that positive and negative charges are bound to each other. That is, they will move together. ये आपस में bound हैं, ये एक साथ move करेंगे. What are the free charges? The electrons that jump out of the atom and are free to conduct current, they are called as free charges. And the electrons inside the atom are bound charge. Now, whenever you apply an electric field on a dielectric, all the dipoles are aligned because the positive charge experiences a force parallel to the field, negative charge opposite to the field. पॉजिटिव चार्ज पे फोर्स लगता है फील्ड के पैरेलल, नेगेटिव पे लगता है अपोजिट. तो सारे डाइपोल फील्ड के डायरेक्शन में अलाइन हो जाते हैं. तो दिस प्रोसेस ऑफ अलाइनमेंट ऑफ डाइपोल व्हेन एक्सटर्नल फील्ड इज अप्लाइड इज कॉल्ड एज पोलराइजेशन. नाउ पोलराइजेशन वेक्टर माने द ओवरऑल डाइपोल मोमेंट डिवाइडेड बाय वॉल्यूम ऑफ द मटेरियल. देखिए, व्हेन ऑल द डाइपोल्स बिकम अलाइंड, so their dipole moments are in the same direction, so they will be added. So the total dipole moment including all the dipoles divided by the volume is the polarization vector. It is proportional to the field and the proportionality constant is epsilon naught chi e. तो जितना फील्ड लगाते हैं उतना ज्यादा पोलराइजेशन आता है और बीच का कांस्टेंट है epsilon naught chi e. Chi e is called as electric susceptibility. That is the tendency of a dielectric to get polarized. So that means if the material has high susceptibility, the dipoles are easily aligned. Low susceptibility mane it is difficult to align the dipoles. So now beta, whenever you place a dielectric between the plates of capacitor, the plates of capacitor carry equal and opposite charges, right? Capacitor की plates पे equal and opposite charges होते हैं, because of which there is the electric field. There is the electric field from the positive to the negative charge, and this electric field will be responsible for aligning all the dipoles in the direction of field within a dielectric. But if you keep on increasing the electric field, the force on the positive and negative part of a dipole keeps on increasing. Electric field बढ़ाते जाओगे तो प्लस और माइनस चार्ज पे फोर्स बढ़ता जाएगा, एंड आफ्टर अ सर्टेन वैल्यू ऑफ इलेक्ट्रिक फील्ड द डाइपोल विल ब्रेक इनटू पॉजिटिव एंड नेगेटिव चार्जेस. दिस इज नोन एज अ डाइलेक्ट्रिक ब्रेकडाउन. इसे कहते हैं डाइलेक्ट्रिक ब्रेकडाउन, एंड द वैल्यू ऑफ इलेक्ट्रिक फील्ड एट विच इट हैपेंस इज नोन एज डाइलेक्ट्रिक स्ट्रेंथ. तो कितनी मैक्सिमम इलेक्ट्रिक फील्ड एक डाइलेक्ट्रिक झेल सकता है, इससे पहले कि उसके अंदर ब्रेकडाउन आए, दिस इज कॉल्ड एज डाइलेक्ट्रिक स्ट्रेंथ. So now we will talk about capacitors, beta. Capacitor is a device which has a certain capacity of storing the charges. So the plates of capacitor carry equal and opposite charge. One plate will be positively charged, one plate will be negatively charged. And what will be the charge on each plate? That depends on the potential difference between the plates. दोनों प्लेट के बीच में पोटेंशियल डिफरेंस कितना आ रहा है, उससे डिसाइड होता है कितना चार्ज आएगा. तो कैपेसिटेंस बेसिकली रिप्रेजेंट्स द कैपेसिटी ऑफ चार्ज स्टोरेज. तो अ कैपेसिटर विद हायर कैपेसिटेंस कैन स्टोर मोर चार्ज, लोअर कैपेसिटेंस विल स्टोर लेस चार्ज. So the unit of capacitance is farad. Now how to find capacitance? First beta, using the Gauss law, we try to find the electric field between the plates of capacitor. Using electric field, we find the potential difference. Then charge upon potential difference is the capacitance. For parallel plate capacitor, the capacitance is A epsilon naught epsilon R by D. What is A? A is the area of the two plates. D is the distance between the plates. Epsilon naught epsilon R is the permittivity of the dielectric between the plates of capacitor. दोनों प्लेट्स के बीच में जो डाइलेक्ट्रिक लगा है वो आपका क्या होगा, वो आपका परमिटिविटी होगा एप्सिलॉन नॉट एप्सिलॉन आर. पक्षी जी आपका डाउट भी क्लियर हुआ कि नहीं हुआ बताइए. नाउ whenever the two plates are having opposite charges, obviously they will attract each other. Now what is the force? Whenever you want the force, you find the electric field because of one plate, multiply it with the charge on the other plate. Now I consider this as infinite sheet. Sir, why do you consider the sheet of capacitor as infinite sheet? Because the area of the plate of capacitor is much larger than the distance between the plates. क्या होता है, कैपेसिटर की प्लेट का जो साइज है वो प्लेट्स के बीच के गैप से बहुत ज्यादा है, एंड दैट इज द बेसिक क्राइटेरिया फॉर कॉलिंग समथिंग इनफाइनाइट. तो इनफाइनाइट प्लेट का लॉजिक ही ये होता है बेटा कि प्लेट का साइज प्लेट के सेपरेशन से काफी ज्यादा आ जाए. Now you know, because of infinite sheet charge, the electric field is rho s by 2 epsilon. Then I will multiply it by q. Rho s by 2 epsilon आती है ना infinite sheet की, into q. Now rho s is q by a, so you will get q square by 2a epsilon. That is the force. If you divide it by area, so force per unit area is q square by a square, which is rho s square. So rho s square by 2 epsilon, this is force per unit area, or we can call pressure. Now beta, because of the electric field between the plates of capacitor, the dipoles will become aligned. So there is a dielectric charge that is induced. On one side of the dielectric, you will have all the negative charges. On one side, you will have the positive charges. तो मैं क्या बोल रहा हूं? Due to electric field, now beta, due to electric field between capacitor plates, the dipoles within dielectric are aligned. Due to which we observe negative charge on one side and positive charge on other side of dielectric. Now this is called as induced charge. The value of induced charge is beta q up into 1 minus 1 by epsilon r. ये induced charge होता है, ठीक है. Now beta, I told you that the plates of capacitor are treated as infinite sheets. But is it practical for anything to be infinite? No, sir. Practically, the sheets will have certain edges. Now, at the edges, we observe that the electric field is not perpendicular to the plate, it is taking a curve. तो हम क्या देखते हैं कि एजेस पे इलेक्ट्रिक फील्ड पूरी तरह से फ्लैट नहीं बनती है, ये कर्व कर जाती है. Now this curving of the electric field or spreading of the electric field at the edges of a plate is known as the fringing. So this basically increases the effective cross section area and it increases the capacitance of the plate, parallel plate capacitor. तो क्या होता है, जब इलेक्ट्रिक फील्ड ज्यादा एरिया में फैलती है तो हमारा जो इफेक्टिव क्रॉस सेक्शन एरिया होता है वो ज्यादा आता है और एप्सिलॉन ए बाय डी के हिसाब से कैपेसिटेंस भी ज्यादा आता है. What if I place a metallic slab between the plates of the capacitor? Now inside a metallic slab beta there can be no electric field. Metallic slab के अंदर कोई electric field नहीं हो सकती. So when we place a metallic slab, if this plate is carrying a charge density plus sigma, minus sigma will be induced here. Now this slab was electrically neutral. To make the net charge 0, plus sigma is induced here. देखो आपने ऊपर क्या लगाया, प्लस सिग्मा का प्लेट लगाया, उससे यहां माइनस सिग्मा इंड्यूस हुआ. अब क्योंकि ये इलेक्ट्रिकली न्यूट्रल है तो यहां पे प्लस सिग्मा आ गया ताकि नेट चार्ज 0 और ये वाली प्लेट पे था माइनस सिग्मा. Now this A distance does not have any electric field, does not have any potential difference. So the separation that I will take will be D minus A by 2, D minus A by 2. So I will treat it as two separate capacitors connected in series. Why series? Because these points are at same potential. Why same potential? Because this is a conductor. A conductor is always equipotential. ये माइनस सिग्मा और प्लस सिग्मा का पोटेंशियल सेम आएगा. काहे? क्योंकि भैया ये कंडक्टर के दो हिस्से हैं और एक कंडक्टर के दोनों हिस्सों पे पोटेंशियल सेम आता है. तो यू कैन ट्रीट इट एज टू सेपरेट कैपेसिटर्स कनेक्टेड इन सीरीज. So whenever you place a metallic slab, it will divide the capacitor into two parts and the two parts are said to be connected in series. Logic समझ में आया? सीरीज क्यों है? ठीक है. क्रैश कोर्स बेटा एक बार ट्राई कर लो, अगर आपको समझ में आ रहा है, क्वेश्चन बन रहे हैं तो आप कॉम्प्रिहेंसिव छोड़ सकते हो. ठीक है. So the net capacitance will become epsilon naught A upon D minus A. ठीक है. तो नेट वही आ जाएगी एप्सिलॉन नॉट ए अपॉन डी माइनस ए. कैसे? क्योंकि देखो ना यहां पे C1 और C2 दोनों बराबर आएंगे एंड व्हेन यू कनेक्ट देम इन सीरीज, you know by network analysis, if two equal capacitors are in series, the net capacitance will be C by 2 epsilon naught A by D minus A. So the shortcut would be reduce the separation between the plates by an amount equal to the thickness of the slab. आप D की जगह डिस्टेंस लेके चलिए D minus A, जहां पे A क्या है? स्लैब का थिकनेस है. नाउ शेयरिंग ऑफ चार्ज, ये तो मैं आपको बता ही चुका हूं. दिस यू कैन इवन डू बाय कैपेसिटेंसेस आल्सो. तो नाउ बेटा व्हेनेवर यू कनेक्ट द टू चार्ज कंडक्टर्स टुगेदर, द चार्ज इज रीडिस्ट्रीब्यूटेड सच दैट potential becomes the same. So we saw that charge density is inversely proportional to radius, electric field inversely proportional to radius, energy density inversely proportional to radius square. But when we are applying charge conservation, actually the energy is not conserved. The initial and final energy is not the same beta, and that energy is actually being lost in the form of heat and the light. So energy lost हो जा रही है. ठीक है. So if you want, you can do it by capacitance. How? The initial charge is Q1 plus Q2. The final is Q1 dash plus Q2 dash. After connection, potential should be same. Now charge is capacitance into potential, ठीक है, CV. So you will say Q1 dash by Q2 dash is C1 by C2. Now what is the capacitance? Capacitance of a isolated sphere is given by 4 pi epsilon r. So the ratio of capacitance is ratio of radius. Therefore charges are divided in the ratio of radius. ये मैंने आपको पहले डायरेक्टली बताया था पोटेंशियल से. अभी आप कैपेसिटेंस से भी वही चीज समझ रहे हो. चार्ज का रेशो रेडियस का रेशो है. ठीक है. So now it will mean that Q1 dash is Q2 dash into R1 by R2. Now because Q1 dash plus Q2 dash is Q, you can write Q1 dash as Q2 dash R1 by R2. So from here you will get Q2 dash and Q1 dash. ठीक है. Total charge is divided in the ratio of their radius. So common potential is total charge by total capacitance, that is Q1 by Q2 upon C1 by C2, C1 plus C2. So this is true beta whenever you connect two capacitors together in parallel. ठीक है. This is always true when two charged capacitors are connected in parallel. Why I am saying parallel? Because beta in parallel connection potential is same. And our entire assumption of this derivation was that both sphere or both capacitor hold the same potential. यहाँ पे यही तो assumption लेके चले थे कि दोनों का potential same आना चाहिए. तो इलेक्ट्रिकल नेटवर्क के टर्म्स में पोटेंशियल पैरेलल में सेम आता है. बट इफ यू सी द एनर्जी, द इनिशियल एनर्जी इज हाफ C1 V1 स्क्वायर, हाफ C2 V2 स्क्वायर. फाइनल इज बोथ हैविंग द सेम पोटेंशियल. What is that potential? C1 V1 plus C2 V2 by C1 plus C2. So if you subtract initial and final energy, you get this value. So this is the loss of energy in the form of heat and the light. Now what happens when we insert a dielectric between the plates of capacitor? So the first case is if the battery stays connected. अगर बैटरी कनेक्टेड ही रहती है और फिर हम डाइलेक्ट्रिक डालते हैं कैपेसिटर की प्लेट्स के बीच में. नाउ पोटेंशियल इज कांस्टेंट बिकॉज ऑफ द बैटरी. नाउ चार्ज विल बी CV. So when you insert the dielectric, you are actually increasing the relative permittivity or you are increasing the permittivity. So capacitance will be increased by a factor of epsilon r. कैपेसिटेंस कितने फैक्टर से बढ़ जाती है? एप्सिलॉन आर के फैक्टर से. तो द न्यू कैपेसिटेंस बाय ओरिजिनल कैपेसिटेंस रेशियो इज एप्सिलॉन आर. न्यू बाय ओल्ड का जो रेशियो है वो एप्सिलॉन आर है. ठीक है. तो द चार्ज विल आल्सो इंक्रीज इन द सेम रेशियो, वोल्टेज विल रिमेन द सेम एंड एनर्जी विल आल्सो इंक्रीज बाय द सेम रेशियो. आप समझिएगा, डाइलेक्ट्रिक डालने से परमिटिविटी बढ़ी, कैपेसिटेंस बढ़ी, पोटेंशियल सेम था बैटरी की वजह से, तो चार्ज का भी वही रेशो आया एप्सिलॉन आर, कैपेसिटेंस का भी वही रेशो आया, एनर्जी का भी वही रेशो आया, which means the energy also increases. Now where does this extra energy come from? It comes from the battery. ये extra energy बैटरी से आई है. Now if battery is disconnected, the battery cannot supply any more charge and therefore we have to assume that my charge is constant. Now capacitance is increasing by a factor of epsilon r whereas the charge is constant. So now I will say potential difference is the charge upon the capacitance. So potential difference will decrease by a factor of epsilon r. इस बार मैं क्या बोलूंगा? चार्ज सेम है, पोटेंशियल डिफरेंस आपका घटेगा क्योंकि आपका कैपेसिटेंस बढ़ रहा है. तो पोटेंशियल डिफरेंस इज गोइंग टू डिक्रीज बिकॉज द कैपेसिटेंस इज इंक्रीजिंग. So V2 by V1 will be 1 by epsilon r. Now the formula of energy that I will apply will be Q square by 2C because charge is constant. So energy will be inversely proportional to capacitance. and hence energy will also decrease by a factor of epsilon r. Now, sir, where does this energy go? This energy will be lost in the form of heat and the light. ठीक है? So energy will be lost. तो आपने क्या देखा? When battery is connected, the new and the old charge ratio is epsilon r. The new and the old energy ratio is epsilon r. The energy increases. Extra energy is supplied by battery. When you disconnect the battery, the charge remains constant. Capacitance becomes epsilon r times. Potential difference reduces by a factor of epsilon r. Energy reduces by a factor of epsilon r. Now, capacitance of a isolated sphere is 4 pi epsilon r. So, first of all, understand why I am defining capacitance. There is no opposite charge here. So, we assume, beta, okay, we assume that the negative charge, that is minus q, is located at infinite radius. मैं मान लेता हूं इसका जो अपोजिट, जो इसका काउंटर पार्ट है माइनस क्यू, वो इंफिनिटी रेडियस पे. सेकेंड, even a isolated conducting sphere can hold the charge on its surface. अगर एक नॉर्मल सा स्फीयर भी है बेटा, अपने सरफेस पे तो चार्ज रख ही सकता है. And if it can store the charge on its surface, it has a capacity of storing charge. It can be treated as a capacitor. अगर ये चार्ज होल्ड कर सकता है तो इसे कैपेसिटर की तरह ट्रीट किया जा सकता है. नेक्स्ट इज द सिलेंड्रिकल कैपेसिटर. It is basically a coaxial cable. Coaxial cable माने there are two coaxial cylinder, inner cylinder and the outer cylinder. Now the inner cylinder has a radius A, the outer cylinder has a radius B, and the length is L. So the capacitance is 2 pi epsilon upon ln B by A, outer radius by inner radius into the length. ठीक है? आयुष भाई कह रहे हैं कि सर पुराने लेक्चर नहीं मिल पा रहे हैं. ये बताओ आयुष भाई कहां पे ढूंढे हो कि पुराने लेक्चर नहीं मिल पाए. नाउ स्फेरिकल कैपेसिटर. इन स्फेरिकल कैपेसिटर वी हैव टू equal and oppositely charged sphere, one having a radius r1, other having a radius r2. R1 is the inner radius, r2 is the outer radius. The capacitance is 4 pi epsilon r1 r2 by r2 minus r1. ठीक है? So that is spherical capacitor. Now sometimes beta, to increase the capacitance or to modify, rather than placing just one dielectric between the plates of capacitor, we place multiple dielectrics. ठीक है? तो अगर मैं एक डाइलेक्ट्रिक की जगह मल्टीपल डाइलेक्ट्रिक लगाऊं तब क्या होगा? बात ये है. So when you take it in series, remember this series and parallel connection formula. ये वैसे भी आप नेटवर्क में पढ़ते हो. In series 1 by C is 1 by C1 plus 1 by C2 up to 1 by Cn. For parallel C is C1 plus C2 up to Cn. In series charge is same, parallel potential difference is same. In parallel plate capacitor beta, I am dividing the thickness into two parts. मैं thickness को दो हिस्सों में बांट रहा हूं. That is, I am placing multiple dielectrics along the thickness of a capacitor. So the first capacitance will become epsilon naught K1. K1 is relative permittivity or dielectric constant. So epsilon naught epsilon R1 by D1. Second one, epsilon naught epsilon R2 into area by D2. Now area is same for both of them. दोनों का area same है, but thickness अलग अलग है. Now beta, whenever you draw the electric field, and electric field comes perpendicular to the boundary of the dielectric. Electric field perpendicular आ रही है दोनों के border के. In that case beta, they are considered to be series connection. So 1 by C is 1 by C1 plus 1 by C2. So that will be the capacitance. So remember, whenever electric field is perpendicular to interface of dielectric, it is considered as सीरीज कनेक्शन. क्या मान के चलते हैं बेटा? तब हम सीरीज कनेक्शन मान के चलते हैं. क्लियर हुआ? नाउ इफ वी डिवाइड द एरिया, I give this an area A1, the other one an area A2. Now see, this is the border of the dielectric. The electric field is always from one plate to the other. So electric field is parallel. You can say electric field is parallel or tangential to interface. Whenever this happens, beta, it is treated as parallel connection. करने को derive कर सकते हो, but जरूरत नहीं है. Now both have the same thickness. Both have the same thickness, but their areas are different. So due to parallel connection, we are directly adding the capacitance. Now in cylindrical, what if I place multiple dielectric? So first let's dissect the formula of capacitance. आइए पहले capacitance के formula को तोड़ते हैं. तो capacitance is 2 pi epsilon L upon log B by A. This 2 pi comes because of phi coordinate. In cylindrical, the phi coordinate varies from 0 to 2 pi. L come because of Z coordinate, because Z is the length of the cylinder. P and A come because of the rho coordinate. The radius varies from A to B. अगर आपको ये समझ आ गया, इस फॉर्मूले में जो तीन टर्म्स आ रही हैं वो तीन अलग अलग कोऑर्डिनेट से आ रही हैं. 2 pi is because of phi, L is because of Z, P and A is because of the limit of rho, that is the radius. Now if I place two dielectric radially, I say from A to C, I have one dielectric, C to B, another dielectric. Now, beta, electric field due to a line charge is in the radial direction. So, it is perpendicular to the interface. So, it will be treated as a series connection. Else, you can do one thing. The border of the two dielectric is rho equal to C. How to find the normal to a surface? Take the gradient. आप किसी surface का normal कैसे निकालते हैं? Gradient लेके. So when the interface is rho equal to C, the normal direction is arrow cap. आपको याद है मैंने वेक्टर कैलकुलस के बेसिक में ये बताया था कि अगर x इक्वल टू कांस्टेंट का प्लेन है तो नॉर्मल ax कैप होता है, y इक्वल टू कांस्टेंट है तो नॉर्मल ay कैप होता है. जो भी कोऑर्डिनेट कांस्टेंट है वही नॉर्मल है. So now the boundary between the two dielectric is rho equal to C. C is the radius that is separating the two dielectric. So normal is arrow cap. Electric field is in arrow cap. I know because the electric field of a line charge is in the direction arrow cap. And cylinder is always treated as a line charge. Cylinder को हमेशा एक line charge की तरह से treat करते हैं और उसकी इलेक्ट्रिक फील्ड एरो कैप में आती है. तो इट इज पैरेलल टू द नॉर्मल. पैरेलल टू द नॉर्मल माने परपेंडिकुलर टू द इंटरफेस. अगर कोई चीज परपेंडिकुलर के अलोंग आ रही है तो सरफेस के परपेंडिकुलर ही कहलाएगी. तो दैट विल बी सीरीज कनेक्शन. फॉर द फर्स्ट कैपेसिटर आई विल टेक लॉग सी बाय ए बिकॉज आउटर रेडियस इज सी, इनर इज ए. फॉर द सेकेंड आई विल टेक लॉग बी बाय सी. Outer is B, inner is C. So C equivalent is the series connection. चमका के नहीं चमका बताइए भाई अच्छे से. First of all, find the boundary between the dielectric. Find the normal. If the electric field is in the normal direction, it is taken as a series connection. If not, then it will be taken as parallel connection. अगर इलेक्ट्रिक फील्ड नॉर्मल के अलोंग हुई तो सीरीज कनेक्शन, नहीं तो पैरेलल कनेक्शन. चमका. नेक्स्ट सपोज बेटा आई डिवाइड द डाइलेक्ट्रिक इन द फाई डायरेक्शन. तो आई से When phi varies from 0 to alpha, I have one dielectric. When it varies from alpha to 2 pi, I have second dielectric. 0 से अल्फा में एक डाइलेक्ट्रिक और अल्फा से 2 पाई में दूसरा डाइलेक्ट्रिक मेरे पास है. Now I know the formula contains 2 pi because of phi. So for the first capacitor, I will use the angle alpha because the width is alpha. For the second, I will use 2 pi minus alpha. Their radius will be same, their length will be same. Now beta, what is the boundary? The boundary is phi equal to alpha. So normal is A phi cap. But electric field is in A rho cap. So it is tangential or parallel. इलेक्ट्रिक फील्ड अगर नॉर्मल डायरेक्शन में नहीं तो क्या कहलाएगी? टेंजेंशियल कहलाएगी. सो यू विल ट्रीट इट एज अ पैरेलल कनेक्शन. आप इसे पैरेलल कनेक्शन की तरह ट्रीट करेंगे, समझे? द बॉर्डर ऑफ द टू डाइलेक्ट्रिक इज फाई बराबर अल्फा, सो द नॉर्मल डायरेक्शन इज ए फाई कैप, while electric field is in a rho cap, so the electric field is not in the normal direction, it is tangential. So we will treat it as a parallel connection. Now if I place two dielectric along the length, अगर length में रखें, so for the first one the length is x, for the second one it is L minus x. So epsilon 1 के लिए L minus x, epsilon 2 के लिए x. Now the border is z equal to x. So normal is AZ cap, electric field A rho cap. Again not in the normal direction, so it will be treated as parallel connection. जब भी electric field normal direction में नहीं होगी, it will be treated as parallel, so I can add the capacitor. Now similarly in spherical, the first let us dissect the formula. The formula is 4 pi epsilon R2 R1 by R2 minus R1. Now this 4 pi is composed of two things, 2 pi and 2. 2 pi because of phi. Phi varies from 0 to 2 pi. 2 comes because of theta. Basically, 2 is the integration of sin theta from 0 to pi. आप ये समझिए बेटा, whenever we talk about the spherical coordinate, theta varies from 0 to pi. So this 4 pi comes because pi varies from 0 to 2 pi and because of the integration of sin theta from 0 to pi, that is 2. 2 into 2 pi is 4 pi. And radius limit is R1 to R2. समझे? मैंने फॉर्मूले को तोड़ दिया r theta phi के अंदर. Now suppose I am placing two dielectric. The first one is from A to B radially, second is from B to C. So what is the interface? That is R equal to B. What is the normal? AR cap. Now sphere is always treated as a point charge. So electric field is in radial direction, AR cap. Because electric field is parallel to the normal, it will be treated as series connection. फिर सुन लीजिए मेरी बात, स्फीयर का इलेक्ट्रिक फील्ड पॉइंट चार्ज वाला ही होता है, यानी कि रेडियल डायरेक्शन में, और नॉर्मल भी AR कैप है. तो जब इलेक्ट्रिक फील्ड AR कैप या नॉर्मल के अलोंग आई तो सीरीज की तरह ट्रीट करेंगे. तो फॉर फर्स्ट कैपेसिटर आई विल राइट AB अपॉन B माइनस A, फॉर सेकेंड BC अपॉन C माइनस B, एंड देन आई विल कंबाइन देम इन सीरीज. चमका ये बात? Suppose I divide the dielectric in theta. From 0 to alpha, I have epsilon 1. Alpha to pi, I have epsilon 2. Now, beta, I have to change this term, which is the limit of theta. So, for first dielectric, I will integrate theta, sin theta from 0 to alpha. For second, alpha to pi. पहले में 0 से alpha, दूसरे में alpha से pi. Then 2 pi AB by B minus A. 2 pi epsilon 2 AB upon B minus A. Because radius of both is same from A to B, ठीक है, and limit of phi will be same, that is 2 pi. So these are the two capacitances. These are the two capacitances then I can combine them in parallel. Why parallel, sir? Because the interface is theta barabar alpha. So normal is A theta cap. Electric field is AR cap. That is not along the normal. So it is tangential. So I will treat it as parallel connection. ठीक है? इलेक्ट्रिक फील्ड जब नॉर्मल के अलोंग ना आए तो पैरेलल कनेक्शन. नेक्स्ट, इफ आई डिवाइड द डाइलेक्ट्रिक अलोंग फाई, तो आई से 0 टू अल्फा फाई इज एप्सिलॉन 1, अल्फा से 2 पाई इट इज एप्सिलॉन 2. तो इंटरफेस बिकम्स फाई बराबर अल्फा, नॉर्मल इज ए फाई कैप, इलेक्ट्रिक फील्ड ए आर कैप. तो इलेक्ट्रिक फील्ड इज टेंजेंशियल, देयरफॉर वी विल यूज पैरेलल कनेक्शन. So for the first dielectric, integration of sine theta is 2. Because of phi I have alpha, epsilon 1 AB by B minus A. Sine theta की वजह से 2. The limit of phi is 2 pi minus alpha. Epsilon 2 AB upon B minus A. तो पहले डाइलेक्ट्रिक की लिमिट है अल्फा और दूसरे की 2 pi minus alpha. साइन थीटा का इंटीग्रेशन 2 आएगा. ओके, जस्ट अ मोमेंट बच्चों. ठीक है भाई, ये चीज क्लियर हो गई ना सभी को? मल्टीपल डाइलेक्ट्रिक वाला बताइए. तो इफ यू कैन ब्रेक द फॉर्मूला ऑफ कैपेसिटेंस यू कैन डील विद डिफरेंट केसेस. नाउ बेटा, व्हाट अबाउट द एनर्जी ऑफ अ कैपेसिटर? वी नो द एनर्जी डेंसिटी इज हाफ एप्सिलॉन मॉड ई स्क्वायर, दैट इज एनर्जी पर यूनिट वॉल्यूम, वेयर ई इज द इलेक्ट्रिक फील्ड. नाउ ई इज rho s by epsilon. Why rho s by epsilon? Because there are two plates. Each plate contributes rho s by 2 epsilon from positive to negative. So total is rho s by epsilon. So the energy comes out as half CV square Q square by 2C और half QV. ये आप सभी लोग जानते हो, है ना, एनर्जी का फॉर्मूला. Now बेटा, how to compute the normal or the tangential component of a field? The normal component or the unit normal is first taken as the gradient of a surface. The gradient is always oriented in the normal direction. So gradient by magnitude is the unit normal. So how to find the normal component of a field? You take the dot product with the an cap, that is the scalar component. Then you again write an cap to show the direction. And tangential component is total minus normal. Total minus normal is tangential. Now it is very important when you study the boundary condition. What is boundary condition? When electric field goes from one medium to the other. अगर electric field एक medium से दूसरे medium जाती है, तो how does the electric field change? That is the boundary condition. So now beta, the condition says the tangential component of electric field is same and the normal component of flux density is same. So ET1 equal to ET2, DN1 equal to DN2. What is D? D is epsilon E. So DN1 equal to DN2 means epsilon 1 EN1 is equal to epsilon 2 EN2. Now rho s is the surface charge density at interface of two dielectric. So if you have certain surface charge density at the boundary of two dielectric, then dn1 is not equal to dn2, but dn1 minus dn2 is rho s. ठीक है, तो dn1 माइनस dn2 क्या होगा? rho s होगा अगर बीच में कोई चार्ज डेंसिटी है. वैसे तो ऐसा होता नहीं है, but still. Now what is refraction? Now ignore there is any charge density at the interface. So first I will talk about tangential component. If the electric field is making an angle alpha 1 with the normal component will be E cos alpha and the tangential will be E sin alpha. So we told the tangential components are same. So E1 sin alpha 1 is E2 sin alpha 2. Then we say rho s is 0. So dn1 equal to dn2 or epsilon 1 en1 equal to epsilon 2 en2. En is E cos alpha. Now if you take the ratio of sin alpha by cos alpha, so tan alpha by epsilon 1, tan alpha 2 by epsilon 2, which means tan alpha 1 by tan alpha 2 is epsilon 1 by epsilon 2. तो ये refraction आ गया basically when the electric field passes from one medium to other, the angle with the normal changes. Now if you take a boundary between the dielectric and a conductor, inside a conductor electric field is 0. So the tangential component in the dielectric as well as the conductor will be 0. Tangential component dielectric conductor दोनों में 0 होगा. So that means sin alpha 1 will be 0 or alpha 1 will be 0. That is the field will be normal to the interface. Electric field आपकी perpendicular ही आएगी. So whenever you connect a dielectric with a conductor, electric field is always perpendicular. अगर आप एक dielectric और conductor को जोड़ते हैं बेटा, तो electric field हमेशा कैसी बनती है? Electric field is always perpendicular. That is the reason why when we place a dielectric between the plates of capacitor, the electric field is perpendicular to the plates. And then dn1 minus dn2 is rho s. Rho s is the charge stored by the conductor on the surface. अब भाई कंडक्टर है तो अपने सरफेस पे चार्ज तो रखेगा, तो यहाँ rho s 0 नहीं होता, तो dn आपका rho s के बराबर आता है, क्योंकि dn2 is 0, it is a conductor. It is a conductor. So electric field and the flux density are 0. So dn1 is rho s. So en1 will be dn1 by epsilon, rho s by epsilon. कंडक्टर के अंदर दोनों चीजें 0 होती हैं. So what did you understand when conductor is connected to a dielectric? First thing, electric field is always perpendicular. Second, En is rho by epsilon. Now beta, whenever you bring a charge near a conducting plane, opposite charge gets induced in the conducting plane because positive will attract the negative inside the conductor. Now it's very difficult to understand how the charge is distributed. ये समझना बड़ा मुश्किल है कि चार्ज कैसे फैला है. And then when we wish to find the electric field or the potential, we have to consider the point charge as well as the induced charge. अब हमें induced charge का आइडिया ही नहीं है कि ये कैसे फैला है, उसे कंसीडर करके फील्ड या पोटेंशियल निकालना बहुत ही डिफिकल्ट है. So we take another situation where we take the mirror image of the point charge about the surface. So if this is q, the mirror image is minus q. It is kept same distance below the surface as the original charge is above the surface. Original charge surface के जितना ऊपर, image charge surface के उतना ही नीचे. Now even this configuration will give you the same amount of electric field and the same amount of potential as this configuration. So what does this help us in? We can replace this conducting plane by this configuration. This is called as the image charge. So the original charge is plus q at a height h above the plane. Image charge is minus q h below the plane. Okay. But if there are two planes at 90 degree to each other, then beta, we have to take 4 image charges. Plus q का mirror image minus q, plus q का minus q, then diagonally you have to take plus q. Why we have taken this additional charge? Because this surface is grounded. It has 0 potential. If I take one charge as q and 2 charges as minus q, the potential will not be 0. So to make the potential 0, we have to take one additional charge q. One additional charge q. तो ये बात ध्यान रखिएगा बेटा, एक एक्स्ट्रा चार्ज क्यों लेना पड़ा? वो इसलिए लेना पड़ा क्योंकि जो बीच का इनफाइनाइट कंडक्टिंग प्लेन है उसका पोटेंशियल 0 आना चाहिए था, 3 चार्जेस से 0 नहीं आ रहा था, तो चौथा चार्ज लेना पड़ेगा. So this is when they are at an angle of 90 degree. Suppose there are two planes at an angle theta. How many charges to consider? 360 by theta minus 1. These are the number of image charges other than the original charge. Original charge के अलावा कितने images बनेंगे? So at 90 degree, 360 by 90 minus 1. So 4 minus 1, 3 image charges. Minus q plus q minus q. ठीक है? Next is the Poisson equation, beta. It relates the potential to the charge distribution. It says Laplacian of V is minus rho V by epsilon. Now it assumes that epsilon is constant. ये मान के चलता है epsilon constant है, यानी dielectric is homogeneous. Now Poisson equation, it helps us in deriving the Laplace equation. So this is the Poisson equation, but for a charge-free region where rho v is 0. So if rho v is 0, del square v is 0. So these are the Laplacian values. Okay, Laplacian values, and we know the Laplacian in general. The general formula of Laplacian valid for all the coordinates. ये मैंने आपको बताया भाई. ठीक है. So this is how we find the Laplacian in general terms. Clear है? Okay, so rho v is 0. This can happen in air or free space, uncharged dielectric, conductor, charge-free region, source-free region, singular charge or a cavity. So in a charged conductor, inside the conductor, rho v is 0. In uncharged conductor also 0. If it is a cylinder, it will hold the charge on the surface. So inner charge density is 0. And even outside the surface, rho v will be 0. Outside the charge sphere, rho v will be 0. Outside the line charge, rho v will be 0. Outside the point charge, rho v will be 0. So charge is basically embedded inside a body. So outside that body, charge density is 0. That is the meaning of singular charge distribution. सिंगुलर चार्ज डिस्ट्रीब्यूशन का मतलब है चार्ज एक बॉडी पे कंसंट्रेटेड है, उसके सराउंडिंग का चार्ज डेंसिटी 0 आएगा. तो हाउ टू सॉल्व द लैप्लास और द पॉइसन इक्वेशन? फर्स्ट जज द कोऑर्डिनेट सिस्टम, देन चेक द पोटेंशियल डिपेंड्स ऑन व्हिच कोऑर्डिनेट. लाइक इन सिलेंडर, सपोज द पोटेंशियल डिपेंड्स ऑन phi, suppose the potential depends on rho. Then in the Laplacian, take only the one term. Laplacian में एक ही टर्म लेनी पड़ेगी depending upon the coordinate. So if potential depends on rho, you just take the first term. Potential depends on phi, you take the second term. Potential depends on z, you take the third term. And then you basically integrate. Let's take an example. I have a conical capacitor. So the potential is V0 at theta 1 and it is 0 at theta 2. So I can say potential varies with theta. Potential theta के साथ vary कर रहा है. ठीक है, theta 1 पे V0 है, theta 2 पे 0 है. So rho v is 0. Between the two plates of the capacitor there is no charge. So del square V is 0. Now potential is a function of theta. For cone I will use the spherical coordinate. So this is my second term. ये मेरी second term आती है 1 by r square sin theta del by del theta. Okay, this term ये मेरे पास आई. Now if it is 0, the derivative 0 माने the term inside the derivative should be constant. So del v by del theta is c by sin theta or c cosec theta. So it will be c log tan theta by 2 plus d. Now how to find c and d? Using this boundary condition. Put theta equal to theta 1, potential is V0. Put theta equal to theta 2, potential 0. So that way you can find C and D. So solution of a Laplace equation will be unique if the potential is specified on the boundary. अगर potential ऐसे boundary पे specify कर दूं तो जो आंसर आता है वो unique आता है. This is uniqueness theorem. Now what is Ohm's law? Ohm's law says beta, whenever there is the electric field across a conductor, this electric field will push the charges and it will create a current through the conductor. The current density is sigma E. Sigma is the conductivity. E is the electric field. For network, we write it as V equal to IR, and this J equal to sigma E is the microscopic Ohm's law. Now, current can also be written as NEAVD. N is the number of electron per unit volume. E is the charge on each electron. A is the cross section area. VD is the drift velocity. The last equation is the continuity equation. Continuity equation tells you about the current because of the charge leaking from the body. So divergence of current density is minus d rho v by dt. That is rate of decrease of the volume charge density. Now what is the relaxation time beta? If you see the continuity equation, if you put J equal to sigma E, so sigma is constant, del dot E is minus rho d rho v by dt. Now E is d by epsilon, del dot d will be rho v by Gauss law. So I will say sigma by epsilon into rho v is d rho v by dt. Del dot d जो होता है वो rho v होता है. So beta, the formula for rho v comes out as rho v naught e to the power minus t by tau. Tau is known as the relaxation time. It tells you the rate at which the charge leaks from a body. It is sigma by epsilon. If the relaxation time is high, the charge will leak slowly. If relaxation time is low, the charge will leak very, very quickly from a body. Next is the Joule's law beta. Joule's law tells you the power, that is rate of flow of energy. So it is force into velocity. So QE into velocity. Q is volume integration of rho v dv, E dot velocity. So rho v into U dv, rho v into velocity dv. Now rho v is Ne, where N is the number of electron per unit volume, E is the charge on each electron. So now power will become E into J dv. E into J dv. J will be Ne into U. जैसे करंट होता है ना, करंट क्या होता है? NEA into velocity. तो करंट डेंसिटी होती है NE into velocity. तो E dot J dv और J सिग्मा E, तो सिग्मा mod E square dv. So when you talk about power density, power per unit volume, it is sigma into E square or J dot E. सिग्मा इंटू ई स्क्वायर और J डॉट E. और यहीं से डिराइव होता है पावर का फॉर्मूला V इंटू आई. Because power is volume integration of power density. Volume is length into area. So now when you take E into length, J into area. E into length is potential, J into area is current. So I into V, I square R और V square by R. तो पावर डेंसिटी कितनी होती है? सिग्मा इंटू ई स्क्वायर, एनर्जी डेंसिटी हाफ एप्सिलन ई स्क्वायर. अब देखो ये सारी फॉर्मूलाज हैं जितना भी आज हमने कवर किया है. आपका इलेक्ट्रोस्टैट मैंने पूरा करा दिया है. ठीक है, अब डेली क्विज पे आ जाते हैं बेटा. चलिए, द वर्क डन इन मूविंग अ चार्ज फ्रॉम प्लस क्यू फ्रॉम ए टू बी इज डब्ल्यू. व्हाट इज द पोटेंशियल डिफरेंस? कम ऑन एवरीबॉडी. If the work done is W, what is the potential difference? बताइए. चार्ज डेंसिटी बेटा जिस पॉइंट पे पोटेंशियल ले रहे हो ना वहां देखनी है बख्शी जी. अब अगर चार्ज मैंने एक वायर पे लिया और मैं वायर के चारों तरफ पोटेंशियल देख रहा हूं तो उस रीजन में तो चार्ज है ही नहीं ना, चार्ज तो वायर पे है, तो वहां चार्ज डेंसिटी 0 ली जाती है. वर्क डन पर यूनिट चार्ज. वेरी गुड. नेक्स्ट, a point charge is placed at origin. Potential at a comma 0 is V. What is the potential at 2a comma 0 0? बोलो भाई फटाफट। Distance of A is D, A. तो VA, VB, EA by, आंसर इज A. B आएगा, सही तो है, VB माइनस VA ही तो होगा, फाइनल से फाइनल माइनस इनिशियल, W बाई क्यू ही तो आएगा। A से B जा रहे हो तो VB माइनस VA ही तो करेंगे, फाइनल माइनस इनिशियल। Now two capacitors are connected in series and charged with a 12 volt battery. What is the energy in C1? What is the energy in C1? बताइए। The equivalent will be, now charge is same in series. (64 माइक्रोजूल). सीरीज में चार्ज सेम आता है तो पहले मैंने चार्ज निकाला फिर एनर्जी। नेक्स्ट, इलेक्ट्रिक पोटेंशियल इन अ रीजन इज गिवन, व्हाट इज द इलेक्ट्रिक फील्ड एट 1,2? बताइए, व्हाट इज द इलेक्ट्रिक फील्ड एट 1,2? Now potential is just given as a function of x and y. Answer is A. Next beta, a dielectric slab is inserted halfway into a parallel plate capacitor connected to a battery. The capacitance, if you are inserting a dielectric slab halfway, माने कि आधे कैपेसिटर में डाइलेक्ट्रिक डाला है, तो what will happen to capacitance? Increases. Whenever you insert a dielectric, capacitance always increases. Very good. For a dipole in a uniform electric field, the system is in stable equilibrium. Stable equilibrium is when minimum energy. When does the energy become minimum? Energy कब minimum बनती है? When it is parallel to the field. ठीक है, आंसर इज सी। वेरी गुड। नेक्स्ट, यूनिट ऑफ फ्लक्स डेंसिटी इज, यूनिट ऑफ फ्लक्स डेंसिटी बेटा, व्हाट इज द यूनिट ऑफ फ्लक्स डेंसिटी? कम ऑन एवरीवन, व्हाट इज द यूनिट ऑफ फ्लक्स डेंसिटी? Same as charge density. Which statement about equipotential surfaces are correct? What statements about equipotential surfaces are correct? Come on everyone. क्या statements सही हैं? Work done will be 0 because there is no potential difference. For point charge, they are spherical. Electric field lines are perpendicular. No, they cannot intersect. Intersect नहीं कर सकते. Very good, Shadow भाई. ABC, Ronak, Subhadeep, very good. When a dielectric is inserted between plates of capacitor with battery disconnected, what happens? If battery is disconnected, what happens, बच्चों? बताइए, अगर बैटरी डिस्कनेक्टेड रहेगी तब क्या होगा? Charge is constant, potential decreases. Yes. Energy will decrease. Energy is lost, capacitance increases. Next करिए. Boundary condition at dielectric interface is no free surface charge. ET1 is ET2, EN1 is DN2. EN1 और EN2 बराबर नहीं होगा ना सुभादीप? Actually DN1 is epsilon 1 EN1, DN2 epsilon 2 EN2. चलिए, see this. If potential is a function of position given by this, if we move from point P1 to P2, the work done will be independent of path and integration of E dot dl on this contour is 0. बताइए, जल्दी से बताइए. बोलो मेरे भाई. The answer is C. Now listen to me very carefully, beta. Whenever any vector field can be expressed as gradient of scalar potential, ये मैंने लाइन इंटीग्रल में बताया था, इट इज सेड टू बी कंजर्वेटिव. तो वर्क डन इंडिपेंडेंट ऑफ पाथ एंड क्लोज लूप लाइन इंटीग्रल विल बी 0. भाई अगर आपने पोटेंशियल डिफाइन कर दिया, अगर आपने पोटेंशियल डिफाइन कर दिया, वहीं से ये चीज एस्टैब्लिश हो गई कि दैट आर फील्ड इज कंजर्वेटिव. एज सून एज वी गेव द पोटेंशियल, it is established that my field is conservative, so work done is independent of path. Chaliye, which of the following statement is true? There can be a stable equilibrium in two-dimensional charge distribution in some region. If E is 0, V must also be 0. The answer is A. Because if E is 0, V is constant. Example, inside a spherical shell, बताया था ना, उसके अंदर पोटेंशियल कांस्टेंट आता है बेटा. एंड स्टेबल इक्विलिब्रियम, लेट मी गिव यू एन एग्जांपल. मिड पॉइंट, फोर्स is 0, since electric field is 0. So this gives rise to a stable. ठीक है, चलिए नेक्स्ट. अ सर्कुलर रिंग ऑफ अ डायमीटर हैज अ चार्ज डेंसिटी. फाइंड द पोटेंशियल एट द सेंटर. आई एम नॉट आस्किंग द इलेक्ट्रिक फील्ड बट द पोटेंशियल. नाउ बेटा, center of ring is equidistant from each point charge on boundary of ring. ठीक है, ऑन बाउंड्री ऑफ रिंग, हर पॉइंट बराबर डिस्टेंस पे. So you can directly add the potential because denominator will be same. So it is same as a point charge. सोच करके देखिए. What I am saying is, if you take any charge, ठीक है, the distance will be equal to r. So what is dv? Rho dl by 4 pi epsilon r. Now if you integrate, you will get this. Now charge density is given 8 into 10 की power minus 6 into 2 pi into radius 4 pi epsilon 9 into 10 की power 9 by radius 1.2. ठीक है, तो 9000 18,000 pi into 8. फोर 52.39 kV. ये लॉजिक समझ में आया बेटा? ये क्लियर हुआ? 1/4 pi epsilon is 9 into 10 की power 9. Electric field of a long line charge at a radial distance where potential is 10 volt is higher than at a radial distance too, where electric field is. तो ये पूछ रहा है ऐसे पॉइंट पे इलेक्ट्रिक फील्ड बताओ जहां पोटेंशियल 10 वोल्ट ज्यादा आता है एज कंपेयर टू 2K, जहां पोटेंशियल जहां पे इलेक्ट्रिक फील्ड है 4. I want the electric field at a point where potential is 10 volt higher than the potential at 2 meter where electric field is 4. करिए इसको ट्राई भाई. देखें भाई, आइए, इलेक्ट्रिक फील्ड ऑफ अ लॉन्ग लाइन चार्ज इज दिस, R is 2, so lambda will be 16 pi epsilon. Now from, I will say, from 2, 1 V2 okay. Lambda by 2 pi epsilon x dx. मैंने क्या बोला कि भाई दो पॉइंट के बीच का जो पोटेंशियल डिफरेंस है वो तो 10 वोल्ट है। अब मुझे नहीं पता कि ये पॉइंट कहां पे है, तो दैट आई नीड टू फिगर आउट व्हाट इज द इंटीग्रेशन ऑफ 1 by x, इट इज log x. नाउ लैम्डा इज 16 pi epsilon. So R is 2e to the power minus 1.25. So what is electric field at R? 16 pi epsilon lambda four divided by e to the power 13.96 वोल्ट पर मीटर। ओके, लॉजिक क्लियर हुआ? पहले मैंने लैम्डा निकाल लिया बेटा, देन आई यूज द इंटीग्रेशन फॉर द पोटेंशियल डिफरेंस। बहुत बढ़िया बेटा। मशीन की बेटा क्लास वेंसडे से स्टार्ट हो रही है, टाइम हो गया है। If potential at a point P due to straight wire of length 2 meter is shown below, if the same wire is made circular with the center at point P, then voltage at P is V2. The line charge density is 10 to the power minus 10, then V2 by V1. देखो अभी मैंने बताया ना सर्कल के सेंटर पे पोटेंशियल, पोटेंशियल at center similarly beta potential at axis of circular ring at height h can use, ठीक है, पोटेंशियल at distance r from log 1 by r. Now line charge density is given, but ये तो infinite line नहीं है, it has a length of 2 meter. Okay. Length is 2 meter, this P is 1 meter. Now if I take a height z, ठीक है, I am taking a point charge at a height z, beta, for these two charges, the distance will be same. Correct? These are the point charges. Okay, like this. Now, beta, I have taken the charge at the bottom and at the top together. So Z will go from 0 to 1. Okay, Z will go from 0 to 1. Now I have to integrate this. Let me take Z equal to tan theta. So dz will be. So whenever beta you do not have a direct formula, always take a point charge and then try to solve. This will be under root 1 plus tan square theta, that is sec theta. Now beta, when z is 0, theta will be 0. When z is 1, theta will be pi by 4. So at pi by 4 it is root 2 plus 1. At 0 it is log 1. Okay. Now beta, the length of the wire is 2. The total charge is Q. The length is 2 meter. When you bend it into a circular ring, the length becomes the circumference. So R becomes 1 upon pi. So when you are keeping it as a circular loop with center at P, so center is at P. What is the electric field at the center? It is 2 lambda Q by 4 pi epsilon R. R is 1 by pi. So lambda by 2 epsilon. Okay? Sorry, potential. So what is the ratio V2 by V1? Lambda by 2 epsilon by lambda by 2 pi epsilon. .4142. So pi upon 3.5644. लॉजिक क्लियर हुआ 3.5644 का? बताइए, लॉजिक इज क्लियर टू एवरीबडी? बोलो भाई जल्दी से, क्लियर हुआ ना सभी लोगों को हाउ वी हैव सॉल्व दिस? चलो नेक्स्ट. A 230 kV RMS 3-phase 50 Hz line, conductor spaced, effective diameter, line charge density. अब यार ये क्वेश्चन जो है ना पावर सिस्टम को बिलोंग करता है. मैं बता देता हूं हाउ टू सॉल्व. इस फैरेड पर मीटर. तो ऐसे, ठीक है. Now see this, three concentric spherical conductor A, B, C of radius R, 2R, 4R respectively. A and C are shorted. B is charged with plus Q. What is the charge on conductor A? Whenever two are shorted, they have the same potential. अब देखिए ये क्वेश्चन मैं कराता हूं, हाउ टू सॉल्व सच क्वेश्चन. Now B is given a charge of plus Q. What is the charge on conductor A? हमें A और C का ऐसा कुछ नहीं, पहले अनचार्ज थे. चलो ये मानना पड़ेगा, नो चार्ज on A and C because they have not mentioned anything about the charges on A and C. So their net charge will be 0. ठीक है? And when they are shorted, their potential should be equal. Now beta, we have given a charge Q to B. Now what happens? What is the potential of A? QA by 4 pi epsilon R. Now B and C lie outside. For a sphere lying outside, the potential inside is same as the surface potential. जैसे B वाला बाहर है तो B के सरफेस पे जो होगा वही उसके अंदर नजर आएगा. सिमिलरली C के सरफेस पे जो होगा वही उसके अंदर आएगा. Now beta, QC will be minus QA. So it will be minus QA by 16. For C beta, for C, all the spheres are inside. When you take a potential due to a sphere inside, take the radius at which you are calculating the potential. वो रेडियस लेके चलिए जहां आप पोटेंशियल निकाल रहे हैं. अगर अंदर निकालते हैं तो बाहर वाला रेडियस लेना है, बाहर निकालते हैं तो भी बाहर वाला ही रेडियस लेना है. Now, because QC is minus QA, this will be cancelled. Now, VA is VC. 3QA by Q by 16, sorry, Q by 8 pi epsilon R. So, QA is minus Q by 3. The option. Now, what is the potential at B beta? Because A is inside. So, you take the outer radius. At B, you take the radius of B only. But for C, B is inside. For C, B is inside. So you take the radius of C. समझे? जब अंदर पोटेंशियल निकालना है तो स्फीयर का रेडियस लीजिए और बाहर निकालना है तो जिस पॉइंट पे निकालना है उस पॉइंट का रेडियस लीजिए. नाउ A is minus Q by 3, तो C will be Q by 3. Take 16 as LCM. So 2Q minus Q by 3. 5Q by 3. ठीक है. अब चलो बाकी क्वेश्चन मैं आपको एज अ होमवर्क दे रहा हूं बेटा। ऑल दीज क्वेश्चंस वी विल डिस्कस टुमारो। तो कल का लेक्चर यहीं से स्टार्ट करेंगे, बना के लाना इसको, ठीक है। कल का लेक्चर भी थोड़ा सा लंबा होगा बेटा, क्योंकि ये क्वेश्चंस भी करेंगे एंड वी विल कंप्लीट मैग्नेटिज्म ऑल्सो। कल ये क्वेश्चंस और मैग्नेटिज्म भी हम लोग करेंगे। ई डॉट डी एल से वे निकालता पोटेंशियल ड्यू टू, निकाल सकते हो बख्शी जी, टाइम लगेगा बट यस यू कैन फाइंड पोटेंशियल। फिर आपको जो इलेक्ट्रिक फील्ड है ना वो फाइनाइट लेंथ ऑफ वायर वाला लेना पड़ेगा, ठीक है। तो बाकी के क्वेश्चन होमवर्क के तौर पे हैं, सॉल्व कीजिएगा। आई विल सी यू टुमारो। थैंक यू एवरीवन, हैव अ ग्रेट